Okay, guys, here are a few problems to help with your Unit 2 review. Remember, we have a test tomorrow over section 1.7, 2.6, and 2.7. Some of the things you guys said you were having problems with were finding domains of functions and just kind of in general knowing what to do when looking for domains. Now, remember, we are doing a very simplified version of this. There are a lot of different rules, a lot of different things that you have to worry about. But I've told you guys in class numerous times, all you really need to worry about for us, for our class, when we're talking about this, when we're thinking of domain, the big thing that you have to worry about is A, do I have any denominators in my, sorry, do I have any variables in my denominator? Or B, do I have any variables in my radical? Okay. So in either one of those cases, that's where you have to watch out. Now I'm going to actually start with this middle function right here, this g of x. Notice I have that x squared, but I don't have any denominators and I don't have any radicals. So I don't really have to worry about it. So my domain literally for this one is all real numbers, and you can write it just with the fun R. We're not going to use set builder notation or interval notation or anything like that. Again, I'm just looking, do you know the concept that, oh yes, I can plug any x that I want to in there and it will work. And that's what happens for that g of x function. If you look at f of x, so I'm looking at the one on the left now, this one right here. If I'm looking at f of x, I notice that I have variables in the numerator, right? X squared plus 4x. I don't necessarily care about my numerator. I know that if I'm looking for a domain here, I can have my function equal 0. That's not a problem. What I can't have is this denominator. If this is 0, with whatever I plug in for x makes it simplify down to 0, then I'm going to have an undefined function and it's not going to work. So what I'm going to do is I'm going to take my denominator, negative 4x squared minus 28x minus 48, and I'm going to set it. And of course, we kind of do the whole not equals 0 just to help ourselves out. I mean, that's basically what we're looking for. The two values that when we plug them in, our denominator is 0, and those are the two values that won't work. For this particular equation, I'm actually going to factor out a negative 4. Okay, negative 4, and that'll be times x squared plus a 7x plus a 12. And again, that cannot equal 0. Now here's the thing, I got this negative 4. I can actually just divide by negative 4, because 0 divided by a number is just 0. So x squared plus 7x plus 12 cannot equal 0. This is a t-chart, AC method, product sum, whatever you want to think about it. You need to factor it. And I need two numbers that when I multiply, I get 12. And when I add them, I get a positive 7. Those two numbers, positive 3, positive 4. So because I just have a 1 in front of my x squared, I can just I go straight to my factored form of x plus 3 times x plus 4. Not allowed to be 0. And then I set each one of those not equal to 0, basically, and I will find out that x cannot be negative 3 or negative 4. So when I write it, I'm going to scroll just a little bit. When I write it, I can write it as domain, capital D, and I can write it, it's all real numbers except x cannot be negative 3 and negative 4. Okay, and again, I'm not worried about set builder notation. I'm not worried about interval notation. I'm worried about the fact that you understand that, you know what, I'm allowed to plug any number I want in there except the negative 3 and the negative 4. And so this right here shows me that you actually know that that's what that means. Okay. So then we need to take a look at h of x, and h of x is got a radical in it. And so what I'm worried about is this radical right here. Okay, I've got an x plus 2 underneath my radical. Because we are dealing with our functions and how they would look graphing, and because we're only currently graphing in the plain old coordinate plane, the xy, not even a three-dimensional coordinate plane, not even an xyz, we don't want to deal with any imaginary numbers. So we don't want, even though I know that, if we took the square root of negative 49, I know you guys would tell me it's positive negative 7i. We're not dealing with our imaginary numbers right now. So what I want is, instead of taking that x plus 2 and setting it not equal to 0, I want to set it greater than or equal to 0. That means that anything that I have then underneath that radical will always be positive. So really then all I need is x is greater than negative 2. And that actually works out to be my domain. As long as I'm plugging in a number greater than -2, then I should be okay. So just a real quick pause on all three of those domains so you can kind of take a look at them. But that should be it. Remember, we're looking for denominator variables in the denominator and variables underneath the radical. Okay?